Okay, in this video, what we're going to be doing is talking about probability in games. So, Victoria is playing a new video game in which the object of the game is to find hidden treasures. To do so, she must travel through several levels, clashing with guards and watchdogs. In one part of the journey, Victoria must pass through two gates, gates 1 and 2, to get to the next level. The chance of gate 1 being open is 20%, which is the same thing as 0.2. The probability that gate 2 is open is 30% or 0.3. And the game designer programmed the gates so that the probability of both being open at the same time is 0.1. So it says draw a model of the situation to help you answer questions 1 through 5. So we're actually going to do two models here. We're going to be looking at a Venn diagram and a tree diagram. So the first thing I'm going to do is a Venn diagram. So let me draw my box here to put it in. Okay, and then inside I'm going to have two circles. Okay, and each of these circles represent a gate. So we've got gate 1 and gate 2. Now, I'm going to start with my probability of both being open. So start here. It says that the probability of both being open is 0.1. Well, on the Venn diagram, the spot where both are open is the intersection of these two circles. So inside these two circles, there's going to be a 0.1. Now it says gate 1 is open 20% of the time. Well, if we already have a 0.1 in the middle here, then that means out of that 0.2, there's only 0.1 left over here. And out of the 30% or 0.3 for gate 2 being open, 0.2 of that goes over here because 0.1 and 0.1 make 0.2, and then 0.2 and 0.1 make 0.3. So you got to look at the intersection being a part of that 30%. And to specify, this 0.1 right here represents only gate 1 being open. And this one right here represents only gate 2 being open. And then outside here, since there's 40% inside the two circles combined, that means there's 0.6 left on the outside. And this 0.6 just represents neither gate being open. So this is our Venn diagram. Okay, and then now we're going to do a tree diagram. I'm going to change colors here. So in the very beginning, okay, if we're looking at these gates, they're either going to be open or closed, right? So I'm going to draw a little key up here. O stands for open, and C stands for closed. Now, if we're looking at this in terms of a tree diagram, we want to look at each gate individually, one at a time, right? So let's look at gate 1. Gate 1 can either be open or closed. So we're going to have open or closed. Now, the probability of gate 1 being open was 20%, right? So 0.2, and then that means it's 80% chance of being closed. And now from each of these branches, we've got gate 2. So gate 2, gate 2. So, and this one can either be open or closed as well, okay? Now, the probability of both gates being open, I'm going to draw this over here. So both gates open. We said that this is going to equal 10%, right? Well, the probability of gate 1 being open is 0.2. If we're looking at the probability of both gates, gate 1 and gate 2, we have to take the probability of gate 1 and multiply it the probability of gate 2. Well, we know that probability of gate 1 being open is 0.2. So 0.2 times what equals 0.1? Well, if we multiply those out, or if we divide 0.1 by 0.2, we'll know that 0.2 times 0.5 is equal to 0.1. So the probability of gate 2 being open after gate 1 is open is 0.5. And since this is 0.5, the remainder goes here, which is also 0.5. Now, gate 2 being closed, if we look at both gates being closed, okay, we've got gate 1 being closed 80%, so we got 0.8, and we're going to multiply that by whatever gate 2 is to equal 0.6. And remember, we said this 0.6 over here represents both gates being closed, right? So 0.8 times what equals 0.6? Well, if we divide 0.6 by 0.8, we're going to get 0.8 times 0.75 is equal to 0.6. So the probability of gate 2 being closed is 0.75. So that means this has to be 0.25. So this one is our tree diagram. Okay. And now it says, what is the probability that both gates are open when Victoria reaches this part of the game? And explain your reasoning. So it told us in the very beginning, the game designer programmed the gates so that the probability of both being open at the same time is 0.1. So we've got 0.1 or 10%. And our reasoning is that they are programmed like that. Okay. And now, question 3, what is the probability that only gate 2 is open when Victoria reaches this part of the game? So there's a couple ways you could look at this. We can look at the Venn diagram tells us that this part of the circle right here represents when only gate 2 is open, right? So the number inside there, the number inside of there is just 0.2. So 0.2 or 20%. Another way you could look at it is a tree diagram. Okay, if I look at this tree diagram, I have to look at gate 2 being the only one open. So that means gate 1 is closed, right? So gate 2 closed is 0.2, or excuse me, 0.8. And then gate 2 open is 0.25. So 0.8 times 0.25, 0.8 times 0.25, that's also going to equal 0.2 or 20%. Okay. And your reasoning, you use the diagrams to help you find it. Question 4 says, what is the probability that neither gate is open when Victoria reaches that part of the game? So if I'm trying to figure out neither, okay, again, if you look at the Venn diagram, we can see neither gate being open is 0.6. And another way you can look at it is, okay, gate 1 is closed and gate 2 is closed. So 0.8 times 0.75. So it's going to be 0.6 or 60%. What is the probability that Victoria finds exactly one gate open? So we're looking at exactly one gate. It doesn't specify which gate, so we got to look at either only gate 1 is open or only gate 2. So only gate 1 or only gate 2. Well, let's go back real quick. Only gate 1 is open. If we look at the Venn diagram, only gate 1 is 0.1. Only gate 2 is 0.2. So only gate 1 is 0.1. Only gate 2 is 0.2. And the word or means addition, right? So we've got 0.1 plus 0.2. So 0.1 plus 0.2, which equals 0.3, or 30%. So we have a 30% chance of exactly one gate being open. Now this next one, it says Victoria encounters another challenge in the game. If she zaps a target in one try, she gets a chance to capture a bonus shield. To capture a bonus shield, she must hit a second target in one try. Victoria can hit a target in one try an average of 60% of the time. Draw a model of the situation to help you answer questions 6 through 8. So, anytime, in order to get the bonus shield, she has to hit the first one and the second one. So, let's look at this as a tree diagram. In the start, right, you've got target 1, which I'm going to shorten to T1. Okay, she can either hit target 1 or miss target 1. So I'm going to say hits target 1 or misses target 1. And we said that the probability of hitting target 1 is 60%, or 0.6. And so that means that it's a 40% chance that she misses it. Now, to get the bonus shield, she has to hit target 2. So target 2, I'm going to shorten that as T2. She has to hit both the first and the second, right? So I'm just going to be focusing on this hits branch for the first one. So she can either hit target 2 or she can miss target 2. Okay? Now, the probability of her hitting the first target and the second target, okay? So we're looking at hit target 1 and hit target 2. Well, her ability to hit any target is 60%, right? So hitting target 1, that's 0.6. Hitting target 2, that's also 0.6. Since we're doing and, it's multiplication, right? So 0.6 times 0.6 is going to give us 0.36. So that is what is going to go right here. Okay, so we've got a probability of 0.36. Now, probability of hitting target 1, hit target 1, and miss target 2. Okay, hitting target 1 and missing target 2. Well, her ability to hit, 0.6. Her ability to miss, we said, was 0.4. So 0.6 times 0.4, that's going to give us 0.24. So the probability of her hitting target 1 and missing target 2 is going to be 0.24. Okay. Question 6 says, what is the probability that Victoria hits the first target? And explain your reasoning. So we've already done all of our reasoning just in the work in this graph right here, okay? So what is the probability that Victoria hits the first target? So we already said it was 0.6 or 60%, right? What is the probability that Victoria captures the bonus shield? That means she has to hit both targets, right? So we said right here that her probability is 0.36 or 36%. And then what's the probability that she hits the first one and doesn't hit the second? So that's what we did right here. We said that that was 0.24 or 24%.